So we are finally on chapter 1. All right, linear equations. So what does that mean, linear? What word do you see in here? Not ear. Line. Yeah. So you see line, all right? So these are equations. What do you have when you have an equation? We really haven't had equations up to this point. We've like simplified stuff. We added things. We multiplied. We do all that kind of thing. We've really never had an equation. What's an equation have in it? An equal sign. That's right. Okay. Linear, because these equations could make straight lines. Okay. They're not going to have squareds and things like that. All right. So let's do a really simple one. We're just start off with an example. I'm not really going to like teach you any kind of special thing. Example 1 on chapter 1. How about that? Now, instead of simplify or add or subtract or multiply or divide, it's going to say to solve. And you're going to solve for the variable. Everybody knows what a variable is, right? A variable is a letter that does what?
It
represents a number, right? It stands for a number. Okay, so we want to find out what this value for x is in order to make the left side equal to the right side. I'm really crossing my fingers on this, and I'm praying that we know how to do this, okay? But I'm gonna show you anyway. This is the first one, example 1. Okay, so here we go. We want to get x by itself. So you always look to see what's being added or subtracted first. That's what you want to get rid of first. What's being added or subtracted to the x? What is that 3 doing to the x? It's being multiplied because it's right next to it. There's no plus in between or minus in between. It's being multiplied. So I don't get rid of that first. There is something that's being added or subtracted. What is that? The 5. It's being subtracted. So that's what we want to get rid of. Now, how do we get rid of something that's being subtracted? We do the opposite. Right, we always do the opposite, so you add the 5. Now, you've learned this from pre-algebra to algebra 1. Probably did a lot of this in geometry as well. And algebra 2. You should have been doing this all your whole high school career at least. So if you do something to one side, talk to me. You got to do it to the other. See, your teachers taught you all this stuff. Good. Okay. So now let's do this. Let's add up all our columns then. All right. We're not really adding anything to the 3x, so I just bring the 3x down. What happens to this? Negative 5 plus 5 cancels out. But more specifically, what does it do? How does it cancel out? Why do we say it cancels out? It adds up to 0. Okay. This adds up to 0. So we don't need to put plus 0 here. So math teachers usually just make it simple, and students usually say it all the time. They just cancel it out. Okay, but I want you to know why they cancel out. All right, because something else is going to cancel out, but not because they add up to 0. They do something else. We'll see that in a minute. All right, put an equal sign. Right, so we got rid of this. What happens here? We just add those columns. So 4 plus 5 is 9. All right?
Divide by 30.
Yep. So now you look at the x, and what is that 3 doing to the x? It's being multiplied. So what's the opposite of multiplying something? We divide it. So this is how I show division. I show it as a fraction. All right, so I put it over 3. Now, what I do to one side, talk to me, got to do to the other side. So I divide that by 3 as well. Now, this 3 and this 3, what do? They cancel out, but they cancel out for a different reason, don't they? They don't cancel out for the same reason. It's a 3 divided by 3. What's 3 divided by 3? It's a 1. What is that 1 doing to the x? Multiplying. So it's 1 times x, which is x. So in effect, we can just get rid of them. But I want you to see why we get rid of them. We get rid of it because it divides out to be a 1. 1 times x is x. These cancel out because they add up to be a 0. 3x plus 0 is just 3x. Everybody see that? All right. I know I'm being a little bit picky on the canceling out thing, but I really think it's important that you see why they cancel out, and we just don't say cancel out all the time. And I'm okay with it. Teachers usually are okay with saying stuff cancels out, but they usually want you to know why they cancel out. So what am I left with? An x. Now we do this division. 9 divided by 3 is 3, and that is our answer. If you wanted to check to see if you got it right, how would you check without looking in the back of the book? Plug it back in, right? That's what I always say. Do your teachers say that? Plug it back in? I had a math professor in college that said plug and chug. All right, so you plug it in and you work it out. That's what he means by plug and chug. So let's put it into the original problem. All right, so our original problem was this. That's our original equation. This is called an equation. Why is it an equation? Because it has a equal sign. Okay, so let's plug the 3 in for this. We can do this in our head, can't we? 3 times what? 3, because x is 3, right? So 3 times 3, which is 9. 9 minus 5 is 4. Does it work? Yes, it works, and it's checked. I'm not going to make you check it, but I think that's important for you to do. All right, let's do another one. Do you think they're all going to be this easy? Okay. So at first, this one, let's change colors. A little sunshine in our life here. So this is example 2. I'm going to show you a little trick to make this a little bit easier. Don't be scared. It's okay. I've got you. Equals 1/3 and then 2x minus 1. What's that?
Why do you have to do that?
Come on.
That's what I'm saying. You didn't even give us no warning.
I didn't give you any warning?
We just straight here.
Is this an equation? Yeah. It's a linear equation as well, because there's nothing x squared, there's no x cubes or anything like that, okay? So I'll give you a hint. Let me ask you this first, before I give you a hint. What's the main thing about this problem that you don't like? And don't say because it's a math problem. The fractions, absolutely. Okay, it's the fractions. Now, I could, I'm not going to, but I could take that 1/2 and do what to that parentheses? Distribute it. It's not FOIL. Okay, FOIL is only when you have 2 things times 2 things. All right, a binomial times a binomial. We don't have that here. It's just plain old FOIL. And we could FOIL this. And we could work it out. All right, if we had time, maybe we'd do it. But it would be a waste of time because that's not how I want to do it anyway. All right, here's what I want to do, and it's going to make things way easier. This has a half. This has a third, correct? Yes. What if I found a common denominator between 2 and 3? What would that be? It'd be a 6. That means, now why did I even go common denominator? I'm not really adding fractions together. Everybody's listening, right? I'm not really adding fractions together, but the common denominator means that the 2 will divide into 6, and the what? 3 will divide into 6. Remember what we said earlier, whatever you do to one side, it's okay as long as you do it to the other side? So what we're going to do is we're going to take a 6, and we're going to multiply it by this whole entire left side. Now, you got to be very, very careful with this. See that minus right there? I'm going to put that whole thing in parentheses. And I'm going to take this. To tell you the truth, you really don't even need that second one in parentheses. You do need this one because of that minus 4. So what I'm going to do is I'm going to multiply by a 6. I'm going to put 6 over 1. Now, whatever you do to one side, you have to do to the other side. So I'm going to multiply that by 6 over 1. Now, watch what happens. The reason that I did that is because we said that 6 is a common denominator. It's the least common multiple. So 2 divides into 6, and 3 divides into 6. That'll get rid of our fraction, won't it? That's the whole idea. That's the whole idea of doing this, so we can get rid of our fractions. You said you don't like the fractions, right? Well, I'm doing you a favor. We're getting rid of the fractions, okay? So let's do this. 2 goes into 2 once, and into 6 what? 3 times, okay? So, what's that? What part? Yeah, 2 goes in. It's just 6 over 2, right? 6 on top, 2 on the bottom. 6 over 2 is 3, isn't it? 6 over 2? That's why that's a 3, right? Because the 6 is on top, 2 is on the bottom, right? 2 goes into 2 once, 2 goes into 6 3 times. That's what I said. We good? Okay. So now you got to be careful with this because it's minus 4. This minus 4 creates a little bit of a problem, all right? But this is going to make it kind of nice. Let's rewrite it without all the stuff canceled out. Okay, 3, and then I'm still going to put that parentheses. What happened to that 1/2? That went away, didn't it? Canceled out. So really, what's in my parentheses here? Yeah, another parentheses, x plus 5, and then minus 4. Okay? So write it down. It's important to keep that x plus 5 in parentheses, put that minus 4 right there. That 3 is being multiplied by that whole entire thing right there. Okay? The right side's a little bit easier. What happens here? 3 goes into 3 once, 3 goes into 6 twice. So now, what's this going to be? It's just a 2 on the outside and a 2x minus 1 inside. That was the hardest part of that problem. The rest of it's not too bad. Okay, I got rid of the fractions. That's what you didn't like. We got rid of them. Now, what we're going to do here, we're not going to take that 3 and multiply through this. What we're going to do is we're going to simplify that first. And that's pretty easy. There's no distributive here because this is a minus. So it's x plus 5 minus 4. What's x plus 5 minus 4? X plus 1. That's right. So I keep the 3 out there. I simplified this to be x plus 1. Everybody see it? All right. Now, I could distribute the 2 if I wanted to. I'll just save it for the next step so I can do the same thing in both steps. All right, so there you go. Plus 5 minus 4 is plus 1. Everybody should see that. Write it down if you're still not sure about it. Now, everybody should be able to do from here on out. And this is stuff that we did earlier, right? We learned how to distribute. We learned how to FOIL and all that kind of stuff. And the reason we did that is so we could do stuff like this. Okay, so what do I do with that 3? Give me one math word. Distribute. That's right. So it's 3x plus 4. It's 3 times 1. Okay, you're multiplying. You're multiplying. Then what's this going to be? 4x minus 2. Now, this is a little different than the first one because you got x's on both sides here. So what we're going to try to do is we're trying to get an x on the same side. Okay? Now, you got a choice. You could take the x's, put it over on the left-hand side, or you could take this x and put it on the right-hand side. Doesn't matter, but I have a preference. You want to hear my preference? My preference would be in this situation to put it on the right so I wouldn't have to deal with a negative. Okay? So I'm running out of time, so I'm going to do this kind of quick. So minus 3x minus 3x. Now, a lot of people would bring everything down. Okay, but you can kind of save yourself a little bit of writing by doing this. You know this cancels out, adds up to 0. I got the x on the right-hand side, so what do I want to get rid of now? The minus 2. Okay, so let's get rid of the minus 2. Let's do it in the same step. So how do I get rid of a minus 2? I add a 2. Do it to both sides. Everybody see that? That cancels. What do I have? 5 equals, what's 4x minus 3x? X. That's your answer. Or I kind of like to write it like that. X equals 5. There it is. So once you understand how to get rid of those fractions, the rest of it's not too hard. Let's do one more. I'm skipping example 3. I forget why, just in my notes I put skip. So, okay. Oops. I just said I'm skipping 3, so this is 4. Here we go. At least I'll get you started off on this. I think the bell might ring halfway through this. Remember what I said earlier before I started teaching this? I said you're going to have to remember some of the stuff that we've done earlier, right? Okay, I'll change it. Is that better? Remember what I said earlier? You're going to have to remember some of the stuff that we learned in the review chapter. What is that? FOIL. That's right. So you're still going to have to remember FOIL. You're going to have to remember a lot of stuff that we did in that review chapter. That's why they reviewed it, okay, so that you could use it later on. Let's do FOIL real quick. 2y times y, 2y squared. Okay, then that's the first. Let's do the outside. That's going to be minus 2y. Let's do the inside. That's plus y. Let's do the last. That's minus 1. Equals. I can do that fast because I've taught this to you before already. Let's FOIL this. Y times 2y is 2y squared. And then the outside, minus 5y. The inside is plus 10y. And then the last is minus 25. If you're not sure about that, go back, watch the video. I can't teach that again. I've already taught it to you. Now what we want to do is we want to get the y's by itself. Watch very carefully, though. I got a 2y squared here and a 2y squared here. Guess what we can do with both of those? Cancel them out. So if they're the same on both sides, I'm just going to cancel them out. What am I going to do here? Negative 2y plus y is negative y minus 1. What's this? Negative 5y plus 10y is positive 5y, and then minus 25. I'll let you do the rest. Now it's basically like what we did before. So I gave you a lesson plan thing on Monday, but here it is. You're doing 9 to 41 odd. Seems like a lot, but lot of these are fairly simple. So it's section 1-1, 9 to 41 odd is pages 94 and 95. All right? That's due tomorrow.